Well, it's nice to be out in the garden again. We had a bit of rain. To be honest, it looks as if it's going to rain again. But it's not too cold. It's about 14 degrees, so the thermometer tells me. And this is an introduction to a fascinating subject which I've never really experimented with before. I'm aware of it, but I've never really had the chance to play around with it. And it's really the opportunity for you, particularly if you've got a small garden, to actually carry out some interesting experiments and to propagate some S9 plus signals around the UK. Yeah, from a small garden. Let me explain more. What I'm going to talk about is called NVIS, Near Vertical Incidence Skywave. Basically, the idea is that you push your signal up at a very steep angle, almost vertical perhaps 80 degrees or 70 degrees, but at a very high angle, such that it comes down around about 200 or 300 miles away. Now, if you look at a typical dipole radiation pattern, the angle of radiation, it tends to go like that, but there's nothing going up like that. So what actually happens is that your dipole will be transmitting a signal at much lower angles and travelling further. But the skip distance, the bit in between, is not covered by your dipole unless you make some changes. NVIS enables you to propagate signals over a range of 200, 300, 400, 500 miles, giving you a much stronger signal than butting down the road with a half acre of ground and dipoles at 60 feet. Let me explain a bit more. Let's go inside. It's a bit warmer and well, it's a bit more cosy. So let's go indoors. NVIS, Near Vertical Incidence Skywave. Bit of a mouthful, abbreviated NVIS, and I think it has been adopted in the past by the military. They may still use it. What NVIS is based around is propagating vertical signals from your antenna. If the signal goes up vertically and hits the reflective layer up in the atmosphere, it comes down pretty close to where it left. If we take a conventional dipole, say a half-wave dipole at a half-wave above the ground, it tends to have a radiation pattern like that. The energy from the dipole leaves at an angle of roughly 30 degrees. It's not a pinprick pencil bit of radiation. It's very broad, but it's basically centered around 30 degrees. And if you operate on the HF band, you'll know that this energy goes up at an angle, it hits the reflecting layer and comes back down at some distant point. The bit in between, from where it leaves your transmitter and where it arrives at the receiving station, the bit in between is called the skip zone. There's nothing there, or very little there, because the signal goes up like that, down like that, and there's virtually nothing in the middle. Now, as I said, this is not a pencil beam. It's fairly broad, but the principle is the same. The bit in the middle is the skip zone, no signal. If we were to change that so that the signal went vertically or near vertically, then it would come down much closer to the point at which it left. In other words, it would come down at the skip zone, in the skip zone. This means to say that you can actually propagate the signal into an area which normally you wouldn't be able to communicate with. Now, the reason for this is various, but from a ham radio point of view, it's very interesting to be able to change the angle of the signal such that you can communicate with stations you wouldn't other communicate with. Now, the difference between a half-wave dipole up there and a half-wave dipole fairly low is quite dramatic. The big difference is that as you lower the dipole, so the angle of radiation increases until you get to a point where it's near vertical. Let me put up on the screen a shot that shows you the principle. This is a half-wave dipole at a half-wave above the ground, and you can see that basically the energy is going in a 30-degree angle. And you can see that there's very little vertical radiation. It's well down, a couple of S points down at least. Now let's put up on the screen another shot of that same dipole, but only an 1/8 wave above ground. So what is an 1/8 wave at 40 metres? Well, an 1/8 wave on 40-metre band is 5 metres, in other words about 14 or 15 feet. You can see immediately that you've got lots and lots of high angle radiation, but very little low angle radiation. So your signal is now travelling at a shorter distance before it hits the Earth again. And there's a big difference in signal strength. Why would you want to do this? Well, simply because you can. Because you can. I've been I've tried to aim a lot of my videos at the guys with smaller gardens, because I think a lot of us have got smaller gardens. And it struck me that NVIS was a very interesting project to perhaps experiment with if you've got a smaller garden. Now let me explain. As you lower the antenna, there's a couple of things that happen. First of all, it's very easy to lower the antenna. You don't need any tall masts, so that makes it attractive for a small garden. Secondly, the antenna tends to be omnidirectional, so it's not really fussy which direction the wire goes. And because of this, if you've got a small garden, you don't have to run your 40-metre antenna in a straight line. A 40-metre antenna half-wave is 20 metres long, 66 feet, give or take. You probably haven't got a garden that's 66 foot long, but you can run it halfway down the garden, say 30 feet, 10 metres, and then run it across the garden, however wide your garden is, and perhaps up the garden a bit. It doesn't really matter. Now, the other thing is that the method of feeding it. If you have a half-wave dipole, you'd normally feed it in the centre with coax cable. Two things happen. First of all, the coax cable doesn't give a very good match to an antenna when it's that low. And secondly, it's an added bit of feeder you've got down the garden, etc., etc. What I've done is I've end-fed my antenna. In other words, I've used an end-fed half-wave. Now, an end-fed half-wave, as I've said before, is very easy, because you've just got to link the wire that goes down the garden, across the garden, and back up the garden a bit. That's your antenna. How do you match it? Well, in a very recent video, I showed you how to make your own low-cost end-fed half-wave matching transformer. All you need is a ferrite ring, which you can get from Radio Spares. You need a capacitor, which you can get from Radio Spares. A bit of tin copper wire, which, if you want to, you can get from Radio Spares. And a plastic box to put it in, again, Radio Spares. So those components are very readily available. You could just make the transformer and put it on the window ledge in your house and then run the wire out the window, down the garden, etc. Therefore you wouldn't need a box. But a box makes it a bit tidier. But the fact is, it's a low-cost matching transformer which anybody can make, and it's a much better way, to my mind, of feeding the antenna. So how low can you go? How low can you get? Look, I'm very conscious that a lot of you, like me, are unable to get out much now. It's not an insult, it's a fact. We don't get out very much now, do we? Because we're of that age. I'm well on the wrong side of 70, and I'm aware that we need to pass the time. So this project is a great project for you if you're confined to the home. the antenna itself is a length of wire. Now, as I said, how low can you go? Well, I found that you can go a lot lower than you might expect. My antenna is about 2 meters above the ground. You can't get much lower than that. And what I'm going to show you now is, first of all, I'm going to show you the antenna. Now, it's probably an insult to call it an antenna. It's rather a length of wire. You may well laugh at it because it's a very sort of temporary arrangement, but it was there to prove the point to myself. And I've also showed you in this video, short clip, some of the stations I was working just to prove that it does work. And as I say, it's a very interesting project if you want to pass the time. We are coming to the spring, of course, which is good, and also the longer evenings. But I would encourage you to try this because it's something that you could do very easily. And as I say, it's great for a small garden. To repeat myself, I believe that if you've got a small garden, you shouldn't treat it as a problem. You should treat it as a challenge. Now, if Joe Bloggs down the road has got 2 acres of ground and 2 Strumeck towers at 60 foot or 80 foot with rotatable arrays on there, well, good luck to him. Good luck to him when the gales blow, when the telescopic tower gets jammed, when the rotator jams in the middle of the winter. There's some problems there. If you've got a small garden, treat it as a challenge. Don't treat it as a problem. Anyway, enough of that. Let's go have a look at my length of wire down my garden, and then to show you how I actually use it on the air. Well, I'm shooting, the sun's coming off at an angle at the moment. Sunshine, gracious me. I've got a mast there which is around about 10 feet high, I suppose, and I've got the end-fed part of the antenna. Zoom in a bit, you can see that. Hopefully you can. There's a box there, and that's where I've mounted the transformer for the. Let's go a bit closer if we can. There's a box there where I've mounted the transformer for the end-fed antenna. And it goes straight down into some shrubs. Let's go a bit further down the garden so you get a better idea. Right, coming further down the garden now, I think you can see the wire going through the shrub there, down to another shrub there, down further down the garden, and it's made of concrete fence post. Don't dismiss it in any way, shape or form. By the way, you're hitting sort of 25/9 here on the meter now, Jeff, from 30JV.
Yep, likewise, Peter, you'll be between 20 and 25 over just a few dBs of QSB on your signal, but yeah, excellent conditions. Excellent, very good. Okay, well, let me fire back down to you there for any final, and I must take a break and go and see how the plumbing's working here. G30JV, GM80SQ.
Yeah, okay, Jeff, GM80SQ from G30JV. Yeah, fine. I really am impressed with this this antenna. If you could see it down the garden, it's just, as I say, 2 meters off the ground, just along the fence here. But it certainly is working on the short skip stations. I heard you yesterday, you're S9 Plus then. Can't hear anything from UK North at the moment in the Midlands, but you're certainly pounded in there, Jeff. Okay, nice to chat again, catch up with you. There's a possibility we might be in the Orkneys later in the year. If we are, I'll get in touch with you, Jeff. From Golf 3 Oscar, Juliet Victor.
That's very good, Peter. Yeah, by all means, my email is on QRZ, so once you got your travel arrangements sorted, Peter, let me know. We'll definitely come across and have a couple of beers with you there. All the best, 73 for now, and good luck with that antenna. It's working extremely well. G30JV, GM8OFQ.
Okay, cheers, Jeff. Take care there. Be seeing you.
Thanks, bye-bye.
Here's another station from the Orkneys coming through at 5 and 9 plus. Tremendous great signal.
Roger, Andrew. Yes, 57 to 58 for you here into Orkney Island tonight, yourself.
And there's not too much else on the band at the moment, but it's a colossal signal. And again, the antenna here is just a couple of metres above ground, and I got a 5.9 plus from him.
5-9 for you. My name is Herdi. Hotel Echo Romeo Delta India. Sierra, Herdi's the name.
Okay, Aldi, from Golf 3 Oscar Juliet Victor, G3 Ocean Japan Victoria. Very good morning to you. And you're also 5 and 9, bit of QSB, but you're 5 and 9. So there we are. That's my antenna and the results I got from it. As I said at the outset, it's ideal if you've got a small garden, and it's a great project to experiment with, because it doesn't really involve too much work. And well, I found it quite interesting. So as usual, thank you for watching this video. I hope it's, I'm not sure whether entertained is the right word, but anyway, I hope you found it interesting. And as usual, enjoy your ham radio, take care, keep safe, and I look forward to talking to you again very soon. Bye for now.